Okay guys, welcome back to the channel, and today we're discussing work. So what is work? It's basically a force times a given displacement. So you can see that in the equation here. We have a force and a given displacement. Now work is a scalar quantity, meaning it doesn't have a direction, it's not a vector, but it's important to consider that the displacement and the force have to be in the same direction. So in this example over here, we have a man applying a force to a large wall, and the wall is not moving. So in this case, if we do our equation over here, the work is going to equal the force times the displacement, but since the displacement x equals 0, then the work equals 0, and there's no displacement and there's no work. And then in this example over here, we have a man walking in this direction with a block. Now you might be tempted to say that the work being done is by the man holding up the block like this while walking, but what is actually going on is the work is being done by the frictional force, which is holding the block in place in the man's hand as he walks in that direction. It is not the man holding up the block. If work was being done by the man's hand, it would have to be if the man was lifting the block, because another form of the work equation is work equals force times displacement times the cosine of theta, which essentially means that work can only be done when it is parallel to the motion of the object. If the force and the displacement are perpendicular, there will be no work done. Now let's talk about the units of work. It's simple to derive. It's newtons times meters, which is also equivalent to joules, which is represented by a J. So one last thing before we go to the practice problem, you can have negative and positive work, and essentially what that means is positive work is when the force and the displacement are both going in the same direction, and when you have a negative work, in the case of frictional forces, you have a force opposing the direction of motion, and that produces negative work. Just remember, when you see a positive and negative, you usually think that work is a vector. It is not, it's a scalar, but the positive and negative values do mean different things. Okay, now we're going to do a basic problem that demonstrates this concept. So a man pulls a block with a 20 Newton force for 10 meters at an angle of 30 degrees from the horizontal. How much work was done? So it might be tempting to just say, oh, work is force times distance, let's just do 20 times 10 and get 200 joules of work. But remember, the work is only the parallel force times the displacement. So the magnitude, we're going to have to resolve it into components and then determine the work done. So we can use this equation, work equals force times displacement times the cosine of theta. So plug in our values. Work equals 20 newtons times 10 meters times the cosine of 30 degrees. And it's going to be essentially, this is 20 cosine, and 10 times 20 root 3, we're just going to keep it in exact form. It's going to be 200 root 3, and the unit of work is joules. So the work done is 200 times the square root of 3 joules of work done. And so that's a basic understanding of work, and we're going to use work and to determine things like power, and it's useful in like energy problems and determining other quantities like that. So make sure you get a good understanding of work, and we'll see you in the next video.